So let's see, I looked at your learning curves, and some of you are late with your work, but those of you who did it, it looked like it went pretty well. Yeah? Okay, that's what it looked like. I mean, the learning curves, nothing was really like under the radar in terms of stuff, so that's good.
Wait, what's our one due yesterday?
Yeah, the learning curve was due yesterday, so get in and do it late, those of you who didn't do it. So Sunday night was the learning curve, and this morning was the homework. You know, I'm giving 80% of the points back, so you need to get in and do it. You know, it's easy, it's kind of freebie points, but you do need to get it in, but it's still well worth going in and doing late. So, okay, so we're gonna look over some problems. What'd you have on this homework? Any ones that you want to go over? On the ceiling?
Yeah.
Okay. Number 16. Let's see, chapter 9. Okay, suppose that a monopolistic seller of flux capacitors faces an inverse demand curve, and that monopolist can produce flux capacitors at a constant marginal cost of 5. How many units will they sell? Suppose that the government imposes a price ceiling of $6. What does this price ceiling do to the monopolist's marginal revenue curve? Specifically, what is the marginal revenue of the 10th, 68th, and 69th? That's the part you want me to review especially? Okay. So you do a little marginal, part A is really marginal revenue equal marginal cost, and get, looks like the quantity of 35.
Yeah.
Okay. So the price ceiling is also the marginal revenue for the first, yeah. So I think, let's see, they didn't give a picture in the book, did they? This one's a little bit easier with a book, or with a picture. Which I'll do on the graph. So do you have the marginal revenue function there? What is it? 40 minus Q. So we got a intercept of 40 and a 1-to-1 type thing going, so this would be 40, right? And then we've got a marginal cost of, what was the first marginal cost? 5. All right, so apparently down here somewhere. So we ended up having an optimal quantity of 35. So it looked like that. Okay. So with a price ceiling, so this thing apparently went something like this with demand curve. What is the price that the monopolist was charging for this optimal quantity of 35? Did they directly ask that or not? Or was it just part of 16? How many units will the profit maximizing sell when the ceiling is in place at what price? So they didn't really ask you to determine the price. Let's do it though. What is the price here? What is that number? Did anybody calculate it? You weren't asked to, so I didn't really expect you to, but you've got the demand curve. 22.5? Okay. Well, you're just plugging in the 35, so 17, so you got 18.5 plus the intercept, or minus the intercept. So what'd you get? 20.5? 22.5. Okay, so in a traditional situation, this would be the monopoly setup, right? Government stepping in and saying, whoa, too high a prices, we're going to impose a price ceiling of, what is it, 6? And the marginal cost was 5. So we want to think about what happens with the ceiling price here at 6. Now, if the ceiling was 24, would there be any impact? No. So if the ceiling price is up here, let me golf club this thing. Let's start to just see when the ceiling becomes effective, as the price ceiling would be 22.5, and then all of a sudden it starts to cause problems in here, right? So what is the revenue generated by additional units when the ceiling is effective? What is the revenue generated by additional units when the ceiling is effective? No. So if the ceiling up here was $24, the monopolist would be $22.50. It'd be an ineffective price ceiling, right? The ceiling doesn't matter because it's high enough. So as the ceiling comes down, now what's the revenue generated by an additional unit? It's actually on an additional unit, so if it wouldn't be a triangle, it'd be 1 unit. So if I produce the 36th unit, how much revenue would it generate if this price ceiling was $20? So what's the revenue generated by the first unit if the price ceiling is $20? So the revenue generated by the first unit with a free market would be this amount, and it would be actually equal to the price, right? Roughly $40, without worrying about discreteness issues. And then the second issue. But with the price ceiling in effect, what is the revenue generated by the first unit? It'd be the price ceiling amount, right? It'd be $20. So what's happened here is that the relevant marginal revenue curve is the ceiling price because it's below the demand curve at these prices. So the revenue generated by each additional unit is $6. It's no longer this because the firm is a price taker. It's actually back to not having any power at all, right? The government is saying, I'm going to tell you that rather than the market, you know, our perfect competition model said that the market spits out this and then Farmer Joe is a price taker. Now the monopolist is taking the price that the government's giving to them, is one way to think about it. And so the analysis is exactly the same. The marginal revenue is going to be equal to the price until the point where it can be lower, which is actually at the demand curve. So I think that's where they're getting their 68 units, because the relevant marginal revenue curve goes like this. This is really the demand curve equals the marginal revenue curve, and then it starts looking like this, which kind of gives a weird looking demand curve. All right, so that's where you get this answer in the back. The price ceiling is also the marginal revenue for the first 68 units. That is the marginal revenue because consumers are willing to pay 6 or more. However, selling the 69th unit requires a reduction in price to $5.50. So we've run it into the demand curve at that point, where now at $5.50, in order to sell additional units, you'd have to go there. So if you take the marginal revenue equal to the demand and solve for that, that gives you 68 right here. If you put 6 into the demand curve, that's going to give you the break point. So the demand curve's kind of kinked. The relevant demand curve is kind of the squiggly line going this way. Okay. Anything else with this problem? Some of the other parts, or is that the part that hung you up? How many units will the profit maximizing monopolist sell? So then we're back to marginal revenue equals marginal cost.
Will we probably have a problem on the test where with producer surplus and consumer surplus for this chapter?
Producer and consumer surplus are probably a possibility anytime, yes. That's at least a possibility. Because with policy issues, that's where we analyze that. It comes into relevance. So the monopolist will sell the first 68 units, price 6, marginal revenue exceeds marginal cost. Monopolist will not sell the 69th unit, as shown in the diagram below. Oh, they did do a little diagram. I didn't even see that. Okay. So that was, is that why you were asking that, Blake?
Mm-hmm.
Yeah. Does that picture make sense to everybody? Has anybody got any questions on the surpluses? Anybody got any questions there? Who? Bright light. There we go. So I still got the deadweight loss. Bonus question for you. When marginal cost is constant at 5, what is average variable cost? What does it look like? What does the average variable cost curve look like for this problem, when marginal cost equals 5? 5, it's the same, yep. So sometimes that comes into play too with the break-even analysis. So remember that, yeah, you remember that, or you had one like that?
No, I said
Oh. So yes, it's 5. So the reason that is pretty simple. If we go back to average variable cost, it's equal to the change in total variable cost, also the change in total cost, right? But the change in total cost from the change in quantity. A 1 unit change leads to a change in variable cost. Variable costs are changing by 5 each time, right? Each additional unit costs me $5. The 35th unit cost me $5. The 40th unit cost me $5. So it's always 5 over 1. And so whenever marginal cost is fixed, the average variable cost is actually equal to it as well. Okay. Anything else on this problem or other problems? Number 8. Okay. Number 8, total revenue. Consider the graph below, which illustrates the demand for fluff. Fluff can be produced at a constant marginal cost and average total cost of $4 per case. Draw in a carefully constructed marginal revenue curve. Which part was it, Blake, that you?
The marginal, with the total revenue.
What must the monopolist charge? Calculate. What part is it? Part A? Oh, well, it says draw a carefully constructed marginal revenue curve. Is that the part? I didn't see it asking for total revenue.
Just wanted to go through.
Okay, go through that part, that problem. Let me, okay. So we've got the, can you guys see that okay, or should I put that lamp on? Okay. So the inverse demand function we had to derive, correct? Because it was, we just got a picture in this one, didn't we? Yeah. So we just had this problem right here. So we've got 20, and then we've got rise over run, 20 over 100. So we had to put that into a functional form. So the inverse demand curve ends up being rise over run, 1 over 1/5, 0.2. So there's your inverse demand function. Thus, total revenue is price times quantity. Okay, is this the part where maybe where you're talking about total revenue? Okay. So the substitution that's going on is they just took that inverse demand function and put it times Q so that you had a total revenue function. And then marginal revenue can be represented by this. I don't know what, again, that would kind of be, I don't know why they did it that way. They didn't, I think they gave you extra information that you didn't really need. That's what I was going to say. The calculus part here would be taking this first derivative gives you that, but doing it the way we were doing it, remember, just take the inverse demand function of 20 minus 0.2, multiply the, because of the twice the slope element here, 0.2 times 2 equals 0.4. And so you get the marginal revenue. Okay. And then the rest of it, marginal cost equals marginal revenue. Then it just kind of flowed through from there. Is there anything else in that problem you want me to look at, Blake? What's that? Nah? Okay. All right, any other ones? Good. All right, let me collect those. And we will pull out chapter 10. So again, the test is going to be through, I don't know. Okay. Oh, you lost a little data there. So the test is going to go through that chapter 9. So that is where you need to be for it. Anybody want help? Is that right? 6 through 9? Yeah. Okay. So last time we looked at some the issue of price discrimination. Started talking about the comp list, and that was a little bit off topic, but that's certainly kind of relevant. So let's take a look at this first problem, 10.1. Oh, sorry. That's right. So, a firm with market power faces an inverse demand curve for its product equal to that, and assume that the firm faces a marginal cost curve of that function. If the firm cannot price discriminate, what is the profit maximizing level of output and price? Okay, so this is back to pretty much the last chapter's calculation. So, you've got a marginal cost curve, you've got an inverse demand curve. what is the profit maximizing level of output? Where marginal revenue equals marginal cost. So you don't have a marginal revenue curve, so the first step would be to derive that. There's your inverse demand function. So I would maybe rewrite that function. And now write the marginal revenue function, maybe below it somewhere. Just put MR right underneath the P. Keep your equal signs lined up is a good technique. So if that's your inverse demand curve, that's got the, why don't you make a little picture over here. So if that's the inverse demand curve, what's the intercept? So put price and quantity. Oops. And then how you learned it before, but y equals a plus. So what's the vertical intercept for your demand curve? A little slow.
Yep.
Solve, this point is the origin, right?
Yep.
So shove in quantity equal to 0 and tell me what P equals. So that's it. That's the vertical intercept, right?
Yeah.
So now just drawing some old demand curve, I don't really care. Now graphically, the marginal revenue curve is twice as steep as the demand curve. Right? So we got that thing where if you drew it perfectly, that would be at the midpoint of that. So this is 2 times the slope of that. So it's 2 times that slope. So marginal revenue, is 100. There you go. Now you got marginal cost is given to you. Set those two equal to each other. Set it up, keep your equal signs. Nice. From the, oops, you guys get an extra credit point today. From your inverse demand curve, you need to get the marginal revenue curve.
That's just a problem from last chapter, but I figured since this was the original equation we had, we need to times this part of
Right, but you want to do that from the inverse demand curve, not from the regular demand curve.
Okay.
This is the regular demand curve, this is the inverse. So what you drew here is what we always draw, right? Except put your quantity and your price here. So that kind of helps. But put your quantity on the, label your axes. Yep. So you got 100, so the marginal revenue curve is twice as steep and starts there. And that's just drawing a picture, which isn't required here, but kind of helps you remember then it's 2 times that. So 100 minus 20Q is the marginal revenue function. All right, P equals 70. Q equals 3. Doing good. Okay. All right, so after setting marginal revenue equal marginal cost, Q equals 3 and price equals 70. So that's kind of the monopolist's price and quantity. Part B, if the firm cannot price discriminate, what are the levels of consumer and producer surplus in the market, assuming the firm maximizes its profit? Calculate the deadweight loss from the market power. So this one, some of you started on your pictures. That's probably the best way to tackle this. So you had 100, there was your demand curve, you had a marginal revenue curve. So kind of put the pieces of the puzzle together. What your marginal cost curve started off at 10 and went up. Marginal Marginal cost equaled marginal revenue at 3. Charge to price is 70. So let's kind of review. What's this? Consumer surplus. Okay, so area A is consumer surplus. What's this? Deadweight loss. This. Area B, which kind of covers all that. That one's a little bit trickier. And then we got this area C. So you got to start filling in the missing pieces and then do some areas. I just did area B and C so that you guys had some anchoring spots on your graph to solve. B and C is producer surplus, that's right. So producer surplus is the difference between the price that the producer is getting, which is $70, and the minimum amount they must get, which is the marginal cost curve. So area B and C is producer surplus. So make sure you're getting that, yeah, it's right over to that spot. Okay, good, yep, that's right, with the quantity. This is not right. Did you do demand equal marginal cost to get a 5? Is that a 5? Or is that where your marginal revenue curve intersects? Oh, okay, but you need to have this intersection point, which ends up being 4.5. Maybe you're not even to that part yet, but well, in order to calculate the deadweight loss area, you're going to need that quantity there, and that is not 5. Yeah, it's not 5. Yes, we don't want to assume. It only makes an ass out of you and me. Remember that old saying? Have you guys ever heard that? Yeah. It's really completely untrue for economics because we assume all the time. Let's assume without any purpose. You guys extra credit points. Okay.
We're on other ones right though.
You know, I didn't even look at your other ones. Once I saw that. Now you're just down to the geometry. No, that's good. Now you're down to the geometry. Yep. Did you get what this point was?
You
Oh, this. You're getting funky on me again with what that number is.
There's 30.
What'd you get?
30.
No. Close. What did you set equal to what? So you should be setting marginal revenue equal marginal cost, and then you substitute in the 3, right? Into the marginal cost or marginal revenue function. So if you go substitute a 3 into there, 3 times 10 is 30, plus 10, 40. Yep. Okay.
That
Yep.
was marginal revenue improvement of marginal cost.
Yep.
Which I thought we already did.
We did, but we need that number right here to do the area. Like of the area for B,
Right.
we would need that number right there.
Right, which is what I'm trying to,
Okay, so how do we get it?
see, that's where I'm kind of stuck, so I thought
Okay.
we already did that.
Where did 70 come from? Show me with your pencil. Like, kind of go through the process of where 70 came from. We were producing, the profit maximizing quantity was 3, and then the price we charged was what? There you go. You went up to what function though?
The demand.
To the demand. Now, if you want to find this number, what do you need to go
So what-
up to?
That one
Yeah.
to the marginal.
Up to the marginal cost or the marginal revenue. Either function
Okay.
would work. So you go up to the marginal cost curve, hang a left. 3 times 10 is 30,
Okay.
plus 10 is 40.
Thank you.
Yeah, I didn't even look that far. Yes. Produce a surplus, yep. Okay, look like most of you are down to your geometry problems here of doing some 1/2 of base times height and so dead weight loss. What's your answer?
22.5.
Okay.
Got 40 and
Work on, you did a little better here. You started to kind of keep those equal signs lined up. I like that. But this is where, like, when I'm grading a test, I'm like, what the heck? What's your thought process? So make sure you're telling a story as you're doing your equations. But yes, that's the correct answer. 2250. Okay, I'll go ahead and write the answers down. Look like most of you are down to your geometry here. So consumer surplus was $45. Producer surplus was 135. And area D was 22.5. 2250. Everybody get there? Or almost there?
So find that point, the bottom point of C,
Yeah?
is that marginal cost equal to 0?
You could hit, no, you're setting the quantity equal to 0 and put that into the marginal cost function. That would work,
Okay.
right? Because you got it, at this point, you're trying to solve for this intercept. So marginal cost equals 10, or it's the vertical intercept of the slope intercept form for what's given there is 10. All right, and then this was 4.5. All right, so it looked like most of you are down to geometry, so we can kind of move on unless there's any questions, but all the base times height, 1/2 base times height, that's all this kind of exercise comes down to. Part C, if the firm has the ability to practice perfect price discrimination, what is the firm's output? What is the firm's output? You should know this, could know this. Should is too strong at this point. You should know that maybe for the test coming up, but you could know this answer like in a snap. if you know what perfect price discrimination is. 4.5. Right. Why? Yes, because marginal revenue equals demand. So with perfect price discrimination, this is equal to marginal revenue with perfect price discrimination, PPD. I don't think I've ever used that acronym before. So then marginal revenue equals marginal cost here. They produce 4.5, and away we go. Now, let's see, is that the next part of this question? What is the firm's output? D. If the firm if the firm practices perfect price discrimination, what are the levels of consumer and producer surplus? What is the deadweight loss from the market power? So, consumer surplus. What's that? Yeah. No. No. Not for this one. Perfect price discrimination. But there is a number for it. But it's a really kind of a small number. You can't even really call it a positive number or a negative number. It's just a number. 0. Yeah, 0. So there is no consumer surplus because what happens is perfect price discrimination verbally means what? What is the producer doing under perfect price discrimination? Getting everything they can. They're charging the highest price people are willing and able to pay for every unit. So the first unit gets sold for this much, the second unit gets sold for this much, the third unit gets sold for this much. So there is no consumer surplus. So consumer surplus is 0. And then what's the deadweight loss? 0. It's also 0 because it's totally squeezed out. What effectively happens is you can kind of conceptually think of it this way, that this just drops over here, so it's squeezing out all the deadweight loss as we move to that point. So there's 0 deadweight loss, 0 consumer surplus. Okay. What is producer surplus? It wasn't asked in this question, but what is producer surplus? The whole thing. A, B, D, C. So by kind of the moral of the story is by having perfect price discrimination, which is, by the way, kind of a theoretical thing. I mean, there are cases where maybe it could approximate it with negotiations, but for the most part, that's almost impossible. But in theory, we get more people consuming the good and we get rid of the deadweight loss. And so we get the welfare of society grows to A, B, C, D, but it's all to the benefit of the producers. Okay. Next problem. Or any last comments on that one?
Did you say consumer surplus and producer surplus was 0?
No. Consumer surplus and deadweight loss. So the answer to C was 4.5. The answer to D was consumer surplus equals 0, deadweight loss equals 0. The bonus information I gave you was producer surplus is actually A plus B plus C plus D. Okay. Next problem. You manage a hair salon that has 2 locations, one in a large city in Ohio with several competing salons and another in a small city in Pennsylvania with less competition. In your Ohio store, your customers' price elasticity of demand is -3, while in Pennsylvania, customers have a -2. Assume that the marginal cost of producing a haircut's $30, regardless of the location. what are your salon's optimal markups and prices at each location? And why do they differ? Okay. So this is touching into some new territory for us. What is your gut reaction here of where higher prices should be versus lower prices? Higher prices in the smaller cities. So the elasticity of demand in Pennsylvania was equal to -2. Is that right? Did I get that right? Yeah. Ohio, elasticity of demand in Ohio was -3. So, which one is more elastic and which one's less elastic? Which one's more elastic, Ohio or Pennsylvania? Pennsylvania's more elastic? Ohio. So be careful. So we got to kind of remember that demand curve, elasticity of demand equals 1 in absolute value somewhere. Over here they were greater than 1. Over here is less than 1. Right? So the elastic range, the inelastic range. As we move this direction along the demand curve, the elasticity gets bigger, becomes more elastic. Now, what in the story tells you that? What in the description tells you that? And I kind of want to make this extra statement here. It's more elastic relative to something. It's relative to our sister store over here in Pennsylvania, right? So it's more elastic. More elastic to what? To pizza, to beer, to, cocaine? What's our more elastic to what? So it's always one thing relative to something else. So it's more elastic relative to Pennsylvania. What in the story kind of told you that?
Competition.
Yeah, more competition. So more competition means more elastic demand. From a graphical standpoint, I'm trying to get all these gut feelings that I want you guys to kind of have as you read these problems. So more elastic means relatively flatter demand or steeper demand? Flatter, good. So flatter demand curve, if we think about a demand curve looking like this versus a demand curve looking like this, right? This one starts to look like an eye is kind of my little cheat as we go. The steeper it is, the more it looks inelastic. The flatter it is, another way to think about it is the more responsive consumers are to a price change. So if you've got a bunch of competition, you raise your price from 30 to 32 bucks, everybody runs to the other salon, right? So you jack your price up and you lose a bunch of business. More elastic. So those are kind of some of the gut feelings as you read problems like this. The intuition that I want you to have, because we're going to get into more sophisticated pricing models now. Okay, so there is a new concept with this problem called the learner index. This is brand new stuff, the learner index. Okay, so this deals with markups. So the learner index uses the elasticity of demand to calculate optimal markups. Optimal markups from marginal cost. And the formula looks like this. Price minus marginal cost divided by price, which is a little bit weird, equals 1 over the elasticity of demand. And then we're going to make this negative. Since the elasticity of demand is always negative, we're going to cancel that out with a negative sign there. So this is the learner index. Now I said it's a little bit weird because if you bought something, pretend you're a business and you bought something for $100 and you mark it up 20%, how much are you selling it for? So you bought something, your cost was $100, and you marked it up 20%, how much are you selling it for? 120, right? That's how the real world would work. Well, here we're doing that a little bit differently because we're taking a $20 markup, the difference between the price and the marginal cost, and we're putting that over the price, which is a little bit weird rather than putting it over marginal cost. So it's not quite perfectly that. That has to deal with tying this back to the elasticity. So I kind of wanted to just call that to your attention that it's slightly weird, but at the same time it's awfully helpful now for businesses to use elasticities and come up with pricing. Because if we know the elasticity of demand, we tend to know our marginal cost, don't we? I mean, again, I want you to put on a real world business hat. Do you know the wholesale cost of an additional unit? If you want to bake some cookies or something and you're in the cookie business, you can kind of calculate your marginal cost, right? How much is that extra unit going to cost you? And then what do I want to sell it for? Well, you want to charge the highest price people are willing and able to pay, which somewhat is dependent upon the elasticity of demand, or is dependent upon the elasticity of demand. So now we're going to use these two features together. And as we start to have a more elastic demand, what happens to that markup? So let's use our numbers now. This ends up being 1/3, right? This ends up being 1/2, 0.5. 50% markup versus a 33% markup. So that's the concept. Now it ties into this. After we do that, we're going to do some algebra, because if we know our marginal cost, we can solve for P. And then that will give us the price. That would be the optimal price. Okay, Max. All right, so we'll pick up there with this problem on Wednesday, but that is kind of the introduction to a little more sophisticated pricing. Max, here's your